Right, this question is asking us to use Gaussian elimination to solve this system of equations. So I've set up our augmented matrix right here. And these numbers are the coefficients for each of our equations. And what we're going to do is just do some row reductions to try to get this to be in the form, like row echelon form. So we want it like this, and it doesn't matter what's out here. So the first thing we can do is go ahead and switch rows so that the first one, the first row starts with 1. So it doesn't matter which row we pick. I decided to switch the rows 1 and 2. So I'm going to start making a note over here as to my row operations. So we switch row 1 and row 2. So that's going to become 6, -3, 3 and 1, -2 and 1, and 1 and 2. And then now what I want to do is take row 2 minus 2 times row 1. And that's going to give me 0, 5, -5, and -15. And the next thing I want to do is take row 3 minus row 1. That's going to give me 0, 1, -4, and 0. And now I'm going to do 1/5, the second row. It's going to be 1, -1, and -3. And now I'll switch row 3, sorry, I'll subtract take row 3 minus row 2. It's going to give me 0, -3, 3. And lastly, I'm going to take 1/3 of row 3. So it's going to change this to 1 and -1. Now I can rewrite. Once I have this last column as a 1, then this is solved in terms of one variable. So then I can just start to substitute it back into the other equations. So this is telling me that z equals -1. This next one is saying that y minus z equals -3. And the upper one is telling me that x minus 2y plus 3z equals 6. So I can just keep substituting. So y equals -3 plus z, which is -1, so that equals -4. And x equals 6 plus 2y minus 3z, so that's going to give 6 plus 2 times the -4 is -8, plus 3, it's going to give us a positive, sorry, a -1, 6, 7, 8, 9, sorry, positive 1. So our final solutions are 1, 6, oh, sorry, wrong one, -4, and -1.